It is in the nature of man that we want to decipher and understand the things around us as precisely as possible. What applies on a small scale can, of course, also be applied to the big picture. For generations, astronomers have been eager to grasp the totality of the cosmos and all its characteristics. However, researchers are confronted with an enormous problem in this respect. From our earthly vantage point, it's simply not possible to survey the entire universe. But does this optical limitation also mean that we will never be able to reach the end of the universe? And does such a thing even exist? Let's dive deeper into this exciting topic today. But before we get started, remember to leave us a like and a subscription in order to join us in the future in seeking the largest secrets of the cosmos. The question of the end. Our view to the stars is limited. The thousands and thousands of celestial bodies that sparkle at us in the firmament by no means reflect the totality of the cosmos. That part of space that we can see from our home planet is appropriately called the observable universe, against the background of the cosmological principle, which states that the universe always presents itself to the observer in the same way. Regardless of his location and direction of observation, there is a spherical space around the Earth, the volume of which corresponds to our cosmic field of view. The optical barrier, which limits our view into the depths of the universe, is called the observation horizon. This is that cosmic area from which information has reached us since the Big Bang. It's known that the birth of the universe took place about 13.8 billion years ago. However, this does not mean that the distance to the observation horizon is also 13.8 billion light-years. In this respect, we must consider namely the steady expansion of the universe, which causes distances to extend subsequently. As a result, our galactic line of sight is about 46.6 billion light-years away from us. With this information in the back of our minds, each of us should understand why the total decoding of the universe presents itself, as some would say, an impossible undertaking. In order to approach the question mentioned at the beginning, whether it is possible to track down the end of the cosmos, or even to reach it, it's first necessary to answer another, more fundamental question. Is there such a thing as an end of the universe at all? Can a construct, which is only too gladly called an infinite structure, possess a marked-out edge? The revealing answer to this question is, we have no idea. This is primarily because the shape and volume of the universe is still the great unknown. Theories in this regard range from a spherical cosmos to a flat, infinitely large one, to a wide variety of geometric shapes, such as that of a donut or a trumpet. In addition, we should remember an important fact when conjecturing about the shapes and dimensions of the universe, which depend primarily on its curvature. Infinity is not the same as unboundedness. In other words, this means, even if the cosmos has a finite volume, it does not mean that it cannot be infinite. To illustrate this thesis, we should look at the often used ant example. If one were to place the little creepy crawly on the surface of a balloon, it would run for any length of time in any direction imaginable without ever encountering a defined edge. Consequently, it would appear to the insect as if it were moving on an infinitely large structure, even though this is of course not true in the case of a balloon. At this point, however, it should be noted that this is a very simplified example, which only serves us in beginning to understand, because in contrast to the balloon, the universe is not embedded in a higher dimensional space within the classical cosmology. Multiverse and Big Freeze. Some researchers answer the question whether the universe has an edge or an end with a decided yes. However, the background of this answer is not quite as simple as it may seem at first. In detail, this assumption is based on the theory of chaotic inflation, introduced in 1986 by the Russian cosmologist Andrei Lin. The core of this hypothesis states that our cosmos does not represent the totality of all things, but merely an infinitesimally small link in an infinite chain of further sub-universes. Consequently, the majority of the universe would continue to expand in an inflationary way since the Big Bang, whereby this development comes to a standstill only in some bubble-shaped partial areas. So every cosmic world could contain its own values of the natural constants, and consequently also completely different physical laws. Theoretically, it's even possible that the individual partial universes can come into contact with each other. However, the question about the end refer not only to the spatial, but also to the existential level of the cosmos. Even if the hypothetical scenarios of the Big Crunch, Big Rip, and Big Freeze differ from each other in detail, the majority of experts agree that the universe will reach its end some distant day. Our current research suggests that the expansion of the universe will continue indefinitely in the future. Against this background, the thesis of the Big Freeze seems most likely. The more the cosmos expands, the colder it becomes. Since the influence of dark energy accelerates the expansion of the universe, according to our present state of knowledge, the space between the individual galaxies will constantly increase too. As a result, photons will eventually be redshifted beyond recognition. As soon as the gas for the formation of new stars is used up and the already existing celestial bodies go out, the cosmos will change gradually into a place of lightless cold. If the proton should be unstable and decay, the remains of the once radiating stars will also be erased from the cosmic world. All that will be left then are black holes. If then the last gravity monsters were evaporated by Hawking radiation, the temperature in the universe would become uniform. Since thermodynamic work is no longer possible, the heat death of the cosmos is sealed. The end as a beginning? However, humans would not be humans if our curiosity for another question were not aroused here. What happens then? In the first moment, a further occupation with the topic seems useless. After our usual understanding, an end always means an absolute end. In this respect, however, some experts suppose that the cosmic end represents by no means an irrevocable end but paves the way for the birth of a new universe. Thus it's conceivable that the cosmos is subject to a steady cycle of decline and ascent, whereby the change point of this rhythm cannot be called a Big Bang, but rather a Big Bounce. In detail, this means the turning point in a continuous cycle of contraction and expansion. Although this hypothesis does not necessarily fit into mainstream cosmology, more and more scientists are moving away from the idea that the much-cited Big Bang really marked the beginning of space and time. The most outstanding evidence for the Big Bang theory is the detection of the cosmic microwave background radiation, abbreviated as CMB. This relic from the primeval times of the cosmos is also isotropic and fills the entire universe. However, the microwave background also represents a tantalizing puzzle for experts. No matter where scientists point their radio telescopes, the radiation always looks the same, and that even in regions that could not have interacted with each other at any time during the past 13.8 billion years. Consequently, astronomers assume that the corresponding areas must have been connected in the past. Without a mechanism which equalizes the temperature in the entire observable universe, the fluctuations in different areas would have to be much higher. One possibility to solve this so-called homogeneity problem is offered by inflation. During a period of insane expansion, the cosmos expanded so incomparably rapidly that most of the universe ended up beyond the regions we can observe today. Although the inflation theory best fits the data collected so far, it's not free of criticism. According to it, we do not know a definitive mechanism that triggered the inflationary expansion, and furthermore, it's impossible to explain what led to the smooth halting of this process. In addition, the inflationary theory makes some predictions that, at least so far, have not come true. In order to break out of the outdated cosmological shackles, experts like Paul Steinhardt decided to say goodbye to the inflationary theory and to pursue new approaches. A new point of view. The biggest problem of today's research would be accordingly the adherence to an incontestable Big Bang theory. Commonly, the birth of the cosmos is interpreted as that process within which space, time, and matter emerged from an original singularity. However, the Big Bounce theory rejects this basic conception. According to it, the Big Bang was not at all the beginning of space and time, but a turning point, or a transition moment from a preceding phase in which space contracted. If we now replace the bang with a bounce, the remote regions of the universe would have had sufficient time to interact with each other and form a single, smooth cosmos in which the sources of microwave background radiation had a chance to balance out. According to Steinhardt, it's possible that time has always existed, and if it has already existed since our own Big Bounce, why shouldn't there have been many? At the end of this train of thought, is the logical conclusion that such a bounce will also repeat itself in the future. As soon as the expanding universe begins to contract and returns to a uniform, dense state, the cosmic cycle could be set in motion again. Now it's your turn. What do you think about these thoughts regarding the spatial and existential end of the cosmos? As always, drop us your thoughts, suggestions, and feedback on today's video in the comments below. Are you in the mood for more exciting contributions on the topic of outer space? Then take a look at the other videos on our channel, which we have linked for you here in the credits. Thanks for your interest. Take care, and we'll see you next time.